Today we look at the real solvation energy. Let's consider the following example. The metal is immersed in a salt solution of the same metal, and between the electrode and the solution an electrochemical equilibrium was established. Since equilibrium was established, the work of ion transfer through the metal solution interface is zero. Take two arbitrary points, one near the metal and the second near the solution. Between these 2 points there is a potential difference which can be measured, the so-called Volta potential metal solution. Then we complete the following process. We evaporate 1 mole of metal atoms, which will require energy. Ionize these atoms near the metal surface at point 1, spending an energy equal to. The resulting electrons return back to metal. The gain in energy will be transfer the metal ions from point 1 to point 2. Since there is a potential difference between these points, the work will be equal to Next, we return metal ions into the solution. The energy effect corresponding to this process is equal to the so-called real solvation energy. To complete the cycle, we transfer the metal ions from the solution to the metal. Under conditions of electrochemical equilibrium, the operation of this process is zero. According to Hess' law, and therefore all values can be determined by experiment, and in this way the real solvation energy of a single type of ion can be determined.